Now, the next form of math we want to cover is algebra, and if I could come up with a term that wouldn't be as scary as that, I would. A lot of times I think maybe I should call this equating or something like that, because a lot of people get nervous when you say algebra, and yet it's very important to. If you understand algebra, I can give you one formula with 3 variables, and you can isolate all of 3 of those variables, which means that instead of memorizing several formulas, you just memorize one, and then know your algebra, and then be able to isolate each of those variables out of that formula. I wouldn't be that nervous about it. There is a mechanical way we can draw a pie diagram, and I'll show you that, but I hope you don't use it. I would much rather have you use the math to isolate the variables out of each of the formulas. To start off with, in algebra, we can show multiplication in 3 different ways. Now, the variables in your formula can be letters, whole numbers, and you have to combine, you see, those different variables. If I use x as a variable and I have several x's throughout that formula, then I have to be able to combine them. But to start off with, let me show you Ohm's law. I think a lot of people know at this time even what Ohm's law represents. In other words, Ohm's law, these are symbols that represent values. In this case, E represents voltage, I represents current, and R represents resistance. Now, having those 2 variables as letters give me a formula that I can use in any problem. Now, when we have 2 letters alongside of one another, that represents multiplication. In other words, I can look at that and know that I have to multiply those 2 values to get my voltage. So I can show multiplication in several ways. I can show it by setting I times R, setting them right alongside of one another. That shows multiplication. I can put I and then put a period right in between them like that, or a dot right in between them right like that, and that shows multiplication. Another one I'm sure you're familiar with is I can put an X between them, and that shows multiplication. Now, I times R, I times R, I times R. Those are ways in which they can be put in a formula. Now, this is going to be the more common way that we'll see it in our formulas. Okay? Now, in division, we can show division in 2 ways. If I write the formula like this, I is equal to E divided by R, I'm showing division that way. Another way I can show it is I can E divided by, and we used this symbol a little earlier, E divided by R. That shows division. Now, the way we're going to use it in the formulas would be like this, and the multiplication would be if I set them alongside of one another. Okay? Now, one of the first things you have to do when you have a formula is to combine terms. Now, there may be times you don't have to combine terms, but other times you may. Anytime you write a formula, you may have to combine terms. Now, the terms can be whole numbers, they can be letters. And you had a practice sheet, an assignment sheet, where you had to combine terms. They weren't formulas. It didn't say equal to a value or anything. All they were was terms. Now, if I had in assignment sheet 1, under block 3-5, under advanced math, you had a formula like this. You had 5x plus y plus 2y. Now, what I have to do is combine those values that can be combined. Now I have two variables. I have x as a variable, I have y as a variable. As you can see, I have 5 beside x. That shows multiplication. I have 5 x's there. Of whatever value x is there, I have 5 of them. Over here, I don't have a 1 in front of that y, but it's understood. If I have a plus y, that's 1y plus 2y. Now there you see I have two values that I can combine. If I have like signs, I will add them together. In other words, if I had two negative signs, I would add those two together. If I have unlike signs, I'll subtract. If I have a plus and a minus, then whichever is the greatest is the value that I would have down here, and so on. If you add, if we know we have two pluses here, we know we have to add them. Then for combining, we would have then 5x plus, we're going to add these two together, plus 3y. Now that isn't an equation, it's just two variables. Now I'll go through one more on combining terms. For number 3 there you had 21 plus 19 plus 12 minus y. Now what I would have to do, if in the front, if there isn't any sign, that's understood to be plus as well. What I would have to do is add those together. I would have 11, 13, I would have 53 minus y. Did I do that right? 11, 12. I would have 52. Get this right here. I would have 52. I got 11, 12, carry 1, 52 minus y would be my answer for combining those terms. Now here I've combined whole numbers. Okay. Okay, now let's go to some equations and then solve some of these equations. I think you'll see where we have to combine some terms. Now, for assignment sheet 2-1, we have 2x plus 3y equals 20. 2x plus 3x equals 20. That's number 1 from assignment sheet number 2 in advanced math. Now, there we have x's we have to combine. It's understood to have a plus out front. That means then I would be adding those two together. They're both like signs. I would add them together and use that sign. If this was happened to be a minus 2x plus 3x, you see, then I would have a plus 1x or x left over, you see. And then I would have, in that case, then I would have x n is equal to 20, see. Now, if I had other whole numbers out here, then I would have to join them together as well. But here I have 5x then is equal to 20. Now, in our work with algebra, anytime we have an equation, you've got a situation there where one side is equal to the other. Now in this case we're looking for the unknown x. Now if x is being multiplied by 5, to get one x by itself, what I'm going to have to do is divide by 5. So that if I want one x alone, I'd have to divide this side by 5. Now whatever I do to one side to maintain that equality, I have to do the same thing to the other side. So then I would have to divide this side by 5. My 5's cancel. I would have then x is equal to 5 into 20 4 times. See? So my x equals 4. Now to prove this out, I can go back to my original formula and plug in times 4 and times 4 again. Then you see I would have 8 plus 12 is equal to 20, or 20 is equal to 20. So we proved that x is the answer for this particular formula. Okay, those should all be somewhat similar. If you have fractions, remember your fractions, and still combine your terms and so on. If I was to put down a formula here now, and of course we've worked with the different variables. If I put down Ohm's law, let me put it down like this. We'll say E is equal to IR. If I would give to you values for let's say current and voltage. No. In other words, I'm not looking for E. I know what E is, and I know what I is. I'm looking for R. What do I have to do to isolate R from the right side of that formula? Now, what you'd have to do, you see, I is being multiplied times R, so that if I want R by itself over here, I would have to divide by I. Now, to maintain the equality in that formula, I'd have to come over here. I would have to do the very same thing over here. Now, my I's would cancel. I'll transpose these now. R then is equal to E over I. So when you get, now at this time you aren't working with Ohm's law. We'll work a little bit with that later. But you see, with that one formula, E is equal to I times R. And those symbols for voltage, current, and resistance could just as well be ABC. They could be any value. However, in Ohm's law, there's certain symbols we want to use that are common throughout all of the electrical trade. Now, you see, we've used algebra on that formula to isolate a different variable out of that formula. In other words, we know that E is equal to I times R. We just found out of that formula, we also know it to be true that R is equal to E divided by I. Now, let's go back and then isolate and see what I, the formula for I would be. In other words, E is equal to IR. We would divide both sides by R, isolating I now, then we would know then that I then is equal to E divided by R. Now we could have any kind of a formula. I could put up a complex formula and you can do the same thing. I mean, you aren't even working with Ohm's law now, and yet we're working with the math part. We're working with the algebra part of isolating the variables out of Ohm's law. Now, let me put up another formula that right now you aren't using, but there's a formula for inductive reactance, which states that you take 2 times pi, which is a constant, times the frequency times the value of L, which is an inductor in henries. Now, you aren't into this. All that means to you right now, or most of you, that it's just a formula. Now we have a constant in here. We have frequency, we have an inductor, and then here's my value of opposition to current flow from an inductor. Now, I could alter this formula. Here's my equal sign right here. I could alter that formula, and let's say I want to isolate L out of that formula. What I could do those values are being multiplied times L. In other words, I could put a dot between each one of those if I want to. Now, if I want to get L by itself, it's being multiplied times all of those. All I would have to do is divide by all of those, and I would have L by itself on the right side of my formula. Of course, what am I missing here? If I do it to the right-hand side, I have to do it to the left as well. Then we would have a formula that would look like this. In other words, Ln is equal to x sub L divided by 2 pi f. Now, you see, I could also isolate the frequency out of there. If I knew, you see that F stands for frequency, I could isolate that out of there too. If I divide both sides by 2 pi L, I would have F by itself over here. Then I would have to divide 2 pi L over here. So you see, by knowing the algebra part of working with equations, you can memorize one formula and you know all of them. Word problems are easy if you know the formula for it, because the variables in the formula tell you what you have to do. In other words, all you have to do when you read say for example, we're going to work with Ohm's law a little bit here, but we know that if I'm looking for the voltage, I'm going to multiply the current times the resistance. All I have to do when I read a word problem is isolate out of there the current and isolate the resistance, plug them in, do what the formula tells me to do, and then I'll have the answer. And of course, there again, your answer, if you put whole units in, you're going to get whole units out. See? So you might have to convert those values to whole units before you put them in. So we'll go on. We'll work with algebra. There's quite a little formula work you're going to have to use before you're out of the program in the next 4 years.